Hi, this is Mr. Ng going over the Chapter 7 test taken on February 17th, 2017. Show all your work and box your answers for the free response. Decide whether each piece of given information alone is sufficient to prove that the quadrilateral ABCD is a parallelogram. So basically, like in the previous video, you're just looking here to use the properties of a parallelogram here. Okay? So E is the midpoint of AC, so I'm using a pencil so I can erase AC. E is the midpoint, so it's it is the midpoint of each of those, and that is true because diagonals bisect. Okay, diagonals, this diagonal cuts in half this diagonal with those two pieces, and this diagonal cuts in half BD with those two pieces. So the answer is yes for that one. Work. The measure of angle ABC, so this big angle down there, remember the second letter is B, so you can kind of basically say this whole angle, and the measure of angle BCD, so over here, is equal to 180 degrees. Well, if it's a parallelogram, then I know that, see how the Paw Patrol, my kids' stickers, both sides are parallel. Okay, so this line is parallel, cut by a transversal, parallel line to the same transversal, parallel line to the same transversal. That means that these two angles are in the interior and they're on the same side, or consecutives. Consecutive angles are supplementary, and you also see that property right here. So that is true. Question number 3, it tells us that AB is parallel to DC, and BC and DA are congruent. Can we say this is a parallelogram? Now, a lot of students are tempted to say right here, the answer is yes, based off of number 6. But here, it has to be the same pair, that one pair of sides. You pick one pair, so let's pick the parallel side. On the same arrowheads should be also the congruent marks. It should look like that. Okay, or up here I should have 2 arrows. Does that make sense? And then that would make it parallel, but because it's not the same side that's both parallel and congruent, then the answer is no. Last question for this one. Angle ABC is congruent to ADC. So I have this. And BAD, so the middle letter is A, so we're talking about up here. And angle BCD, that means this was the middle angle right there. So I have opposite angles are congruent, so that would be yes. Alright, these questions down here. This is question number 5. Solve for the value of x. Okay, something I noticed is that these are representing angles, and these are represented in the interior. So I'm going to write that down, interior. And it's not asking me to find each interior angle. That would be a regular polygon. This is not a regular polygon because the angles are not equal angle. They're not all the same, so they're all different. So what I'm going to have to do is I'm going to have to add them all up. So if I just go around and count, 1, 2, 3, 4, 5, 6. This is a hexagon. 6-sided means there's going to be 6 blanks. 1, 2, 3, 4, 5, and 6. And here, this is where a lot of students like to write 180 or 360, and that would be incorrect. So if I have the words interior and sum, just look here, I have angles, I have interior and sum, so I need to use this equation, n minus 2 times 180. This gives me an interior sum, so then 6 minus 2. I'm going to get 4 times 180, and that'll get me 720. And then I just go around filling it in. Once you pick a spot, put a little check mark to help me remember. 5x, 3x, 4x, 2x, 4x, and 5x. So then you just add these all up. These are all like terms. So 5x plus 3x, I'm just adding coefficients. 5 plus 3 is 8. 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 4 is 18. 18 plus 5 is 23x. Next to each other, so that's multiplication. Pull out my calculator. 720 divided by 23. And I get approximately 31.3. Okay. Question number 6 says to compare the quantity in column A, so the number we get, with the number in column B. The measure of each exterior angle of a regular polygon. So I see some words there, each and exterior. So this is A. And then I go to the map. I have angles, exterior, each 360 divided by m. And it's a pentagon, so n is equal to 5. 360 divided by 5, put that in my calculator. And I get 72. Alright, let's compare that with B now. The measure of each interior angle of a regular hexagon. Again, I usually don't use the each exterior angle formula. I think it's a little bit more difficult, so I just draw this picture. This is the interior, this is the exterior. So if I find each exterior, which I can use this formula, and a hexagon, n equals 6. Then I get 60 for the exterior angle, each exterior angle. And then I just take that number, put it back on my picture. And we're looking for the interior angle, so that would be 120. So the measure of each interior angle is equal to 120. So if I compare these two values, they're not equal, so you can cross that off. The relationship cannot be determined based on the information. We do have enough information. And then we're just choosing which number is bigger, this number or this number. 120 is greater, that quantity is bigger, therefore column B is greater, therefore your answer is B. Alright, number 7, the sum of the interior angles, so I see the word sum and interior, of a polygon. So then just look for sum and interior on my interior sum, n minus 2 times 180. There it is, that's choice 3. Question number 8. Give me all that space. Sorry about that. The measure of n. So n exterior angle, that is each exterior angle. Do you see that? It doesn't say the word each, but that's how it works on my formula sheet. It's just 1. So then it tells you it is 120 degrees. So each exterior is equal to 120 degrees. So I'm just going to highlight that in green here. Now we just used that formula, each exterior, which is 360 over n. From there I'm going to do my substitution, so each exterior is 120. And the problem says, how many sides does the polygon have? So we're going to have to solve for n here. Just put it over 1. Cross multiply, so I get 360 equals 120n divided by 120. And you'll get that to be 3. So D is your correct answer. Alright, go ahead and try this question over here. Directions for questions 9-11. Decide whether the statements are always, sometimes, or never true. I'm going to go ahead and have my map handy. See if I can zoom out so you can see all that. Do the best we can. You should have your map out. The isosceles trapezoid, so I'm going to locate that. That's here in orange, is a rhombus. Okay, so here you are going sideways into different branches. So different branches sideways, the answer is never. Never. In a parallelogram, so here's a parallelogram. And remember, you're going to this box as the diagonals bisect. So that is a factor, a characteristic, or a property of a parallelogram. So you're not going sideways there. It's just in a parallelogram, is this one of the properties? That is always true. And the last one, a rhombus is a square. So we go from a rhombus going to a square. The answer, the reason why a rhombus is sometimes a square is only if all the sides are congruent. It's not always a square because a rhombus doesn't have right angles, so the answer is sometimes here. Okay. Question number 12, solve for y, and then name the property or theorem used. Okay, so if I look at these angles, there are angles. That's something you should be thinking about. Is it angles or sides? They're angles. They're on the exterior. And the difference between questions 8 and 12, the difference between these problems here is that these previous problems, these are regular, which means all of the interior angles and all the exterior angles are going to be equal. Now this one, they're not equal, but I can still use exterior, and then, so I'm not finding each, and that'll be exterior sum is 360 degrees. So here I don't have to count the number of sides, but the sides tell me how many blanks. So I have 1, 2, 3, 4, 5, so I'm going to write 5 blanks. Put all those values in. 60, 65, 60, 70, 1, and 40. And then I'll add up all of those values. So 65 plus 60 plus 70 plus 40. Y plus 235 equals 360. And I'm going to go ahead and subtract 235 from both sides. That's 360. That gives me y equals 125. Let's take a look here. So 2 points apiece, so that's 8 points. 4, multiple choice, 2, 2, 2. Each of these were 2 points, so that's 6, and this one's 4. So I have 12, 14, 16, 18, 24, 28 for that side. Let's go with this one. Alright, for this question here, it tells me to find the missing angles, and I recognize that I have these markings. So it doesn't tell me what type of problem it is. And if I notice, I have 2 congruent sides, and they're called consecutive. Consecutive just means that they're next to or adjacent. Okay, so I have 2 consecutive congruent sides. This is called a kite. And if you look on your map on kite, look at the properties. Let's get it in here. And if I look at the first property, I don't have any diagonals. Okay, 2 pairs of consecutive sides are congruent. We already used that one. Opposite sides are not congruent. Okay, not talking about sides, I'm talking about angles. 0 pairs of parallel lines. Okay, that's not helping me. That just helps me identify between the different branches. So I'm going to go back up to this one. Exactly 1 pair of opposite angles. I know you guys can't see that, but it says in the included angle. The included angle we talked about in class is the 1-2 sandwich. The 1-2 sandwich. So essentially what that means is between the 1 congruent mark and the 2, these are congruent. So this will be 112. We can call that one x. Measure of angle A, that's 112 degrees. These angles are on the interior, and I need to add them all up, so that is called sum. So interior sum is n times n minus 2 times 180, and if you just put in there 4, because it's 4-sided, then you can do n equals 4, put in there, 4 minus 2 is 2, 2 times 180 gives you 360. The shortcut is it's just a quadrilateral sum theorem. And you just go ahead and put in all your values. So I got 86, 112, 112, and x. So 86 plus 112 plus 112 gives me 310. And go ahead and subtract 310 from those sides. You're doing the opposites. X equals 50. Alright, this question, most difficult for students. In the figure below, the measure of angle BCD is 125. BCD. So this whole angle is 125. BD, so the diagonal there is 74. I'm going to write, because I know in a parallelogram, diagonals bisect, so if this is 74, this will be 36, 37 each. And AE is 29. So again, diagonals bisect, diagonals, the two parts are congruent. Use the figure below to for the parallelogram ABCD, so we're going to use the properties to find the missing sides and angles. Okay, we can go ahead and cross this part off. We don't need to justify. We just need to find these answers. Okay, so ED is 37. AC, 29 plus 29 is 58. And AD, I can do opposite sides of a parallelogram are congruent, so that's 33. Question number 17, angle BAD. So here, they're saying this little angle is 25, but if I go from here all the way to over here, that's opposite angles are congruent, so that'll be 125. ACD, okay, that's not 29, that's the diagonal that's bisected, so here this would be 25, so this angle here is 25. That's parallel lines to the same transversal, alternate interior angles are congruent. Angle ABC, so this angle up here, well, these two angles are consecutive interior angles are supplementary, so that's blank plus blank equals 180. The number added to 125, so the supplement of 125 is 55 degrees. Question number 20. A regular polygon has 10 sides. I try not to draw 10-sided items. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Not enough? 9 and 10. Find the measure of each interior and each exterior. In class we talked about how it's going to be easier if you just start with the exterior angle first. And you can use this picture if you like. What I showed you in class is kind of like this right here. So this is the exterior and this is the interior. And it has 10 sides, so that means n is equal to 10. So each exterior is equal to 360 over n, so 360 divided by 10, because of the 10 sides, gives us 36. So 36 degrees is my answer. Each exterior is 36. And all I have to do is that the interior plus the exterior are supplementary. If you extend that line there, so interior plus the exterior. Exterior is 36, so I just need to find a number that is a supplement, and that would be 144. Again, you'll notice those two answers are supplementary. Question number 20, you just need to match. Give the most specific name for the quadrilateral. So I see two sets of parallel lines. That would be a parallelogram. I notice I have all sides are congruent, but I notice that there are no right angles, so that would be a rhombus. I have two sets of parallel lines. Okay, so I know it's a p-gram. Okay, then I recognize something about the diagonals. Now here, diagonals, you could argue that it either bisects, or we can also say that diagonals are congruent, so more specifically this would be a rectangle. Remember, parallelogram versus rectangle, this is the most specific name, that would be rectangle. And the other one is if I see these numbers, that's 80, 92, 90, and I think that's 88. So if you add those numbers together, I get 180, 180 to maybe it's 98. Let's double check. 80 plus 90 plus 92. That number is supposed to be 98. That would be a quadrilateral E. And the last problem, it's the can-cans. Fill in the square so that each row and column contains numbers 1 to 4. Numbers in each cages may repeat as long as they are not in the same row or column. Please do these with a pencil. I'm going to look for the free freebies, so I can only use numbers 1, 2, 3, and 4. Here's my freebie. Doesn't have a math operation. So this is a cage. I need two numbers that add up to be 3. So I know those two numbers would have to be 2 and 1. I can't put a 1 here because it would be repeating. So I'll put a 2, then a 1 here. Let's go to another 2 box. Let's go up here. Now I'm just trying to, I get the freebies, now I'm going for the easier one, so that's only just 2 boxes. So two numbers that multiply to be 8 are 2 and 4, but I can't put a 2 here because they're repeating, so I have to put a 4 here, and a 2. Then notice that this column is missing just the number 3. So I've got that. Here's another 2 box, 2 numbers that add up to be 4. That'll be 3 and 1. Again, I'm not sure at this point where that's going to be, so I'll just put a 3 and a 1 here. Okay. For the 3s with the corners, I can either use 4 times 1 times 1. That's a possibility. Or I can also use 1 times 2 times 2. Now if I'm going to choose, I can't choose 4 times 1 times 1, because if I put the 4 here, that would be 1 and 1, and those are repeating. If I put the 4 here, that would be 1 here and a 1 here, and that would be repeating. So I'm going to try 2, 2, and 1. So I can't have 2 2's adjacent or next to each other, so 2 times 1 is 2, 2 times 2 is 4. And in this column, I'm missing the number 4. And this row, I'm missing the number 3. Goes really quickly at the end, missing the number 4. And you can check that 4 plus 3 is 7, 7 plus 4 is 11. Here I'm just missing some couple of numbers, so that'll be 4. And this number is 3. You'll notice that there's no repeating numbers in the rows, no repeating numbers in the columns. In this last one, 3 plus 3 is 6, 6 plus 4 is 10, so that works out. So the points for this problem are going to be, let's see, 4 points here, 2 points each, so 1, 2, 3, 4, 5, 6, that's 12 points. Over here I said 4 points each, so 4 and 4. and 2 points each, so 2 times 4 is 8, and Ken is 4. So that would be 16, 20, 24, 32, and 36. So if I add the two numbers together, 36 plus 28 gives me 64 points. Hope this test corrections were helpful for you for your next test.